Today we'll be discussing radical review and rationalizing the denominator. Radical expressions, simplifying radicals, and rationalizing the denominator are all concepts from Algebra 1, but we will review a few examples here today. Let's recall. An expression that contains a radical sign, as noted here, is a radical expression. There are many different types of radical expressions, but in this course, geometry, as well as from algebra, you will only be studying the radical expressions that contain square roots. A few examples here are some radical expressions. You'll notice that you see numbers as well as variables incorporated within that radical symbol. The expression under the radical sign is called the radicand. A radicand may contain numbers, variables, or both. It may contain one term or more than one. Now let's look at a few examples. We've got the square root of 8 times the square root of 6. Let's put both of those numbers underneath the radical symbol. So we would have our symbol, then 8 times 6. 8 times 6 is 48. So now let's rewrite that. So we have the square root of 48 here. And now we want to look for factors of 48. If we take two factors of 48, we have 16 times 3. This makes it easier because we already know the square root of 16 to be simply 4, and then the square root of 3 will be left in our final answer. So our final answer is 4 times the square root of 3. We can't simplify the 3 any further because its factors are already prime, 3, and 1. So 4 times the square root of 3 is our simplified answer. Now let's look at the second example. We've got the square root of 5 divided by 4. We can take this as well, properties of square roots, and we can rewrite that as the square root of 5 divided by the square root of 4. Here, we should already see something that we recall. The square root of 5, again, already prime, will not simplify further, but the square root of 4 is 2. So our final answer is the square root of 5 divided by 2. Now let's look at rationalizing the denominator. A quotient with the square root in the denominator is not simplified. Remember that the denominator is the number at the bottom of your fraction. To simplify these expressions, multiply by a form of 1 to get a perfect square radicand in that denominator. This process is called rationalizing the denominator. Let's look at an example. We have the square root of 11 divided by the square root of 3. We see that square root of 3 in the denominator and know that we cannot leave it there. It is not simplified. So what we will do is we will multiply by a form of 1. Remember, this is just changing what it looks like. It does not change the actual numbers themselves. So since the square root of 3 is in our denominator, that's what I will take to rationalize with that form of 1. I will take the square root of 3 over the square root of 3. So again, it's the square root of 3 in the denominator. That's what I'll use, numerator and denominator, to multiply by here. So now multiplying fractions, I'll simply take the square root of 11 times the square root of 3, which gives me the square root of 33. And then my denominator, I'll take the square root of 3 times the square root of 3, which gives me the square root of 9. Now here we can see another step left with the square root of 33 left in that numerator, but the square root of 9 is simply 3. So our final answer becomes the square root of 33 divided by 3. We've eliminated that radical in the denominator. Let's look at another one here. We have the square root of 13 divided by the square root of 5. Again, the square root of 5 in that denominator we need to rationalize. So we'll multiply by a form of 1, taking the square root of 5 over the square root of 5. So when I multiply square root of 13 times the square root of 5, I get the square root of 65. The factors of 65 are prime, 5, and 13, so I can't simplify further. The denominator, the square root of 5 times square root of 5, will be the square root of 25. And in my final step, I can simplify. I'll have the square root of 65 in the numerator and simply 5 in that denominator. The square root of 25 is just 5. One more example. This one you'll notice is a little bit different because we have a 2 out in front of that radical symbol. So again, I see I need to rationalize the denominator. Let's start by multiplying with the form of 1. So I'll multiply both numerator and denominator by the square root of 7. When I further simplify here, I'll leave the 2 outside that radical, and then I'll have the square root of 80 times the square root of 7, which gives me the square root of 560. And then my denominator will be the square root of 49, which is the 7 times 7. In my next step, I will take 2, still again on the outside, and then let's factor the square root of 560. I will find factors being 16 times 35, and then my denominator I can go ahead and simplify the square root of 49, which is simply 7. Now, I'll notice that square root of 16 to have a perfect square. So I'll have 2 on the outside times the 4 from a square root of 16, and then the 35 will stay underneath the radical in the numerator. My denominator is still 7. And for my final simplified answer, 2 times 4 gives me 8, the square root of 35, all over 7. So my final answer is 8 square root of 35 divided by 7. If you need any further review on radical expressions, simplifying, or rationalizing the denominator from concepts of Algebra 1, please come by tutorials.